Good afternoon, I'm Vincent Diaz, and this is my presentation for my EE201 term project. What you see in front of you is my screen that I'm recording through my phone. So if it moves around a bit, forgive me. So my project is the lost key and wallet alert system, which I expanded on from my midterm project of the original project was if a door opens and the keys and wallet are not with me, with my phone location, which I assume the phone's always with me, then I will send off an alarm. Now, with the states available, I'm able to add extra components, more realistic components of being able to turn things off and turn things on, because realistically, when you have a circuit or tool, it can't always be on because it wastes a lot of energy, etc. So that's pretty much what I added to this project in that case. So when I started off, the first step was to create a flow chart. Now you'll see your first step is the off state, which is before 7 p.m. or the door does not open. And then second, moved on to the on state if it's after 7 p.m. or the door does open. And if my wallet and keys are with me or with my GPS location, then it returns back to the off state. Now, if it remains in the on state and then the conditions are not met or something is not with me, whether it be my phone or wallet, I left it at home or I left it out, then either sends an alert to my phone or sends off an alert at home. So once it gets that alert, it will send off alert every clock cycle and it will stay in that state until everything is returned. So if we move over to the state diagram, which is drawn out, you see that we have 4 states, meaning 2 D flip-flops, and then you see that it stays in the state if the conditions are not satisfied on my wallet or keys. So initially, I guess I'll also get to this, is I had multiple conditions for it going from off to on, such as the 7 p.m. But during implementation, I started running out of space on the breadboard, which I'll show you what happened later on in the presentation. So I took that condition off since it's just adding an OR gate and wasn't exactly important to the circuit. So you see the condition of 7 p.m. why, but it's not implemented. So just be consistent that the variable X is for the door opens, B, the wallet isn't home, C is my tracker, and then D are my keys are not at home. So then once you get those, the flow chart and the state diagram, we can turn that into truth tables, return to equations. So each state, I listed out the state 1, the inputs X and Y for off, and then the next state. So the inputs for going from off to on are if the door opens X, or it's after 7 p.m. Y. And you see that it becomes an OR, which I ended up dropping to just if the door opens or not. And then secondly, on the on condition, this is where the multiple conditions of not having the wallet or keys with my location, I put that into a 4x1 mux instead of putting a bunch of AND gates in there. Simplifies it quite a bit, and then you end up seeing that for each switch of 0, 0, it's whether I am at home. Sorry, if it's 0, 0, if it's I'm out, and if it's 1, 1, if it's I'm at home, and then 0, 1, 1, 0, they both send out a signal. So that simplifies it into my on state to the alerts, where I pass it as F. The output of the mux is F, which gives me just obviously 2 potential inputs, 0 or 1, and then you tie that on with the GPS tracker of it being at home or being out, and that sends it to the home or the phone alert. And then again, it only goes back to 0, when it's complete or when the conditions have been met. That's the completed logic diagram. Multiple AND gates, 1 MUX, 2 D flip-flops. So then when it comes to the circuit, this is what I'm talking about, where it got a bit messy, where I initially set up my ICs, and then I had 6, and then I realized I didn't have enough space. I'd broken one of my 3-input AND gates, so I was kind of crunched on one, and I had to use another 2-input AND gate, and that just was didn't end up making enough space for the OR gate, and then I needed space for the LEDs, and then I needed the LEDs obviously to see my states. As you can see, the top here are my S1, S0 ons, and my S1 bar or an S0 bar. That way I can tell, and as you can see here, it's at state 1, which is the phone alert. And then I just had these LEDs down here for testing to see which outputs and inputs are working. This was my manual clocks, that's why it's on. When I go to demonstrate the circuit, my clock is on with the function generator. So, and now it's just the door opening. So it goes through the ICs. It's an inverter, my 4x1 MUX, and then these are my 2 AND gates, so it gets lost in the mess. And then 3-input AND gate. This is the D flip-flop. And then lastly, that's the OR gate I had to use later on. The OR gate I had to put back in because I realized I wasn't getting the right high signal. It wasn't, when I was having more than one input into the D flip-flop, sometimes the signal wasn't going through unless I unplugged or unhooked one of the wires. So I'm guessing that's an internal resistance issue. I didn't look too much into it. I don't fully understand the issue. But then when I put it through an OR gate, when I tie it through an OR gate, it gives the correct high signal. Therefore, I was able to get the right circuit. Another issue I had was just that I didn't have enough wires the same color or in length. So it was hard for me to track down issues sometimes. It took a little longer. It got a little messy, but we made it happen. So that's just the troubleshooting, again, that I had mentioned. And then lastly, we'll go over the circuit. So here I already have it on. The function generator is already on. Clock's already running. Again, the inverter, MUX, the AND gates here, and then the D flip-flop. And that's my OR gate over there. So first, let's say we will, oops, I need to run it. Open the door, right? So if we open the door, there we go. Oh, I need to run the function generator. There we go. Okay. So if we open the door, it turns 0, 0 to 0, 1 is on, and it's going off because the conditions are all met. So then let's say we then step outside. Step outside without keys and wallet, it goes to 1, 1 and stays on that alarm, which is the phone alert. So it only returns to off once we go back home with our wallet and items. So with a home alert, let's say we forget our wallet or keys, it goes from 0, 1 to 1, 0 and stays in that state again until something is returned. You can close the door if you want, and the circuit still stays in the alarm system. So we go back, it kind of turns off again. So then the door is closed, so it doesn't go back on. Again, that's if the door opens, goes, and it turns back on. And that's my presentation.